Hey guys, long time no see. Unfortunately, COVID has forced us to drop basically all plans for events recently. Thus, we haven't been able to properly schedule any meetups in the past few months. So sorry about that. But we're back now in business in the online format, and we're willing to give it a try. Uh, we hope you'll like it and find it almost as good, or if not better, compared to the in-person meetups that we used to have. But nevertheless, please don't hesitate to let us know any feedback that you might have for us so we can further improve this format in the future. Lastly, as you've already noticed, we're starting migrating our Meetup community to the new GDG Dev community platform, which is officially provided by Google. The sign-up procedures should be pretty easy since you guys already have Google accounts. I mean, you're Android developers, so hopefully you have some. All future events that we will host, either online or in person, will be hosted on the new platform. So you will have to RSVP over there. It will be a gradual rollout, but we hope that in a few months we will be complete. All right. Now that's out of the way. First, we'll start our event with a short introduction of what are the new features and changes introduced along the release of Android 11. And for that, I'll leave my dearest colleague Cosmin from Greener Pastures to walk you through the new stuff. Cosmin, take it away.
Yep. Hi everyone. Good evening. And yeah, long time no see. It's really nice that we finally get a chance to talk and to see some of the new things that have been changing in the past couple of months. We have some really great speakers lined up for tonight. And thank you, Bogdan, so much. I will start sharing my screen. Let's see if this works nicely. All right. So I hope everyone can see my screen now. If not, I really hope someone can tell me. All right, so hi. Today I'm Cosmin. I've been around the Android space for almost 10 years now, actually a bit more than 10 years now. I'm doing software engineering at Greener Pastures, and tonight is actually about the new, and more particularly what's been happening and what has shown up in Android in the latest version. We'll be chatting a bit about Android 11. We'll also be talking a bit about the tools and, of course, about the latest libraries that have been updated. And some of the great speakers we have tonight will actually be going into more details on this later on. To start with, Android 11 actually comes, as always, with a lot of changes. And the focus for today's presentation is more towards developers and what it actually means for us as Android engineers. And the first topic is going to be UI. One of the things that has been changed in Android, or has been introduced in Android 11, is the window insets system. This has actually been a very a feature that a lot of people have been looking for. And basically through this new system, we are now able to get information about the space in which us as developers of apps, we can basically present our content. As you know, basically our app actually depends on the status bar, and there's also the navigation bar, and also the IME, which is typically basically the keyboard that can pop up on top. And the fact that we can adapt to this has always been a big pain for Android developers. Luckily, in Android 11, they've actually introduced a very nice system based on the window insets, which allows us to set up a listener. And based on that, for example, finally be able to see if and check if the keyboard is open. This is like something that I'm really, really excited about because it has caused me and I guess everyone else a lot of pain over the years. Even more, we can actually even get the insets, as in the amount of space that this keyboard takes in order for us to adapt the UI and show the content properly around the existing keyboard. Furthermore, one of the reasons to update to this window insets system is to enable any animations. And now that we actually have information about the IME, we can actually do perform two things. we can actually synchronize the keyboard animations with what happens on the content size. And basically, we can listen for changes and adapt our UI to that, or we can actually even drive the keyboard animation directly from our code. And here we have some examples, like on the left side, our content, like our layout actually gets pushed up and it reacts to the fact that the keyboard has opened, while on the right side, the keyboard actually gets closed and like the animation for opening the keyboard gets driven by stuff that's happening in our app, in this particular case, scrolling. Google has set up on sample animation that you can find here, and that would be something that's something that I would highly encourage you to take a look at. Also going into the UI, another big thing coming up in Android 11 is the conversations. This is where Android is trying to basically organize the notifications and try to put the content that is most importantly above everything else. So in this case, apps that actually provide conversation have now a technical support for showing content in this conversation section. For example, when you long press on one of these conversations, you actually get a new chance to select its priority. For example, you can prioritize a discussion, and in the end, this ends up putting your conversation on top. So you're sure that always the most important things for you are shown up at the top. Technically speaking, we need to, in order to make this happen from our side, we need to use the shortcuts system in Android to basically specify, for example, here you can see that you can actually build a person and like build the avatar and show information about who has created this conversation. And then we actually create a new notification based on that particular shortcut. You can read much more on this on the existing documentation they have online. One other feature that has been asked for and up until now was being done in a different way is the system of bubbles. You've probably all seen it. Messenger started with that a couple of years ago. And now Android has introduced a native way of showing content as bubbles. Basically, you can surface conversation over the entire UI. And as you can see on the right side, you can actually do this very nice activity or like screen that works and performs nicely. Basically, notifications can be promoted as bubbles, and in Android 10, this has been a developer option. You can always do it like that, but with Android 11, they're here for everyone to use. Overall, they're a much better system than the Android system alert window, which is what was used before, and we create them using the notification API, and it allows us to provide all the necessary metadata. So this ends up exactly as we want it to. And it also allows us to specify a dedicated activity. There are a couple of podcasts discussing this topic about bubbles and the conversations in the Android Developers Backstage podcast. So I highly encourage you to take a look and give it a try when you have a chance. I know like most of these things are exciting for users, but also from our side, we need to do some things to make it happen. All right. Then moving forward, one other very big topic that you've probably seen in the past couple of years in Android has been the big focus on privacy. And Android 11 continues on this journey, which while being a bit annoying for us as developers because we need to take care of all these little issues, it's a really good thing for Android users as a whole because people get to be in charge of what they share, when they share, and what kind of systems and data, private data gets exposed. One of the very interesting APIs and systems that has been introduced in Android 11 is called data access auditing. And this is a system that is meant to provide more transparency into how our apps and actually their dependencies as well, access private data from the users. And as you can see in this image, basically, like this actually makes a lot of sense for bigger apps when you have a huge code base and you might have orphan code or you have some dependencies which are accessing private data. And using this data access auditing, it's really easy to figure out who is accessing what and when. From our perspective, we have support to create a callback that actually gets invoked every time someone requires some data, some private data that should be allowed by the user. Technically, this happens simply by implementing this on-op noted callback, and we have to legislate on the system. And then after that, Android will call those methods every time some private data gets accessed, such as camera, such as storage, such as location, and so on. And it's a really nice way to audit what kind of private data gets accessed and how. Moving forward, you've all been working with permissions. Like it's been like 4 versions already, like since Android 6 that we've had to work with Android permissions. Now they've actually introduced a new interesting bit, which is one-time permissions. These are permissions that the user can grant only while the app runs, like during the current session of the app. From our perspective as developers, this does not require any work if we already follow the best practices. So in an app, if we are already checking for permissions and asking for the permissions, there's nothing that we need to do because the user could have done basically could have disabled permissions anyway via settings up until now so far. Another more restrictive thing is with regards to access to location. So in Android 11, location being accessed from the background has been restricted more. What we need to do is first request foreground permission. That's going to the typical system where we ask for users to give us access to the location. However, if we also want to get access to the location while the app is in background, we need to actually take the user to the settings page and have them allow all the time our system. And this makes their intentions very intentional. It's a bit of a hassle for us from the development point of view, but it's a feature that is probably very interesting for the users. There's plenty of documentation on how this can be done, and there's a lot of support from Google for this. Moving forward, one other thing that has changed is progress, like it's the privacy around foreground services. In Android 10, we already had to specify if in one of our foreground services we're using private information, such as location. In Android 11, they have added the requirement for specifying what we are using, both for camera and for the microphone. And based on this, there are also a couple of changes when it comes to permissions or like what a foreground service can be done. And it has a lot to do with whether it was started while the app was in foreground or not. Please take a look at the documentation and you'll definitely find out more. Besides these, there are also a few other things you should keep in mind when it comes to privacy. One of them is the fact that they introduced package visibility restrictions, which means our app cannot query installed apps anymore. And whenever we are trying to use an external app, we need to actually declare it in the manifest. Secondly, there's the scope storage system, which includes a lot of improvements for developers, allowing us to, for example, access raw path names and do batch editing and so on. And finally, there's an interesting system of auto resetting permissions, which means the system automatically removes our permissions for apps if they haven't been used in a long time. So for example, if our app has been installed and the permission was given 6 months ago, and the user hasn't started it since, it's gonna actually lose that permission. So they actually introduced some very nice APIs in order to allow us as developers to ask the user to basically disable this auto reset permissions feature for our app in particular. But anyway, it's something that you need to keep in mind, and we should definitely take care of it. All right, these have been things that have been, let's say, they require a bit of work from our side. Moving forward, Android 11 actually adds some features that are meant to make things easier for us and to make our experience even more fun and enjoying. First of all, they've introduced Wi-Fi debugging, like as it says here, because there are never enough USB ports, especially with the new Macs and all. But the thing is that, yeah, with Android 11 and Android Studio, like the latest version of Android Studio, we can actually do Wi-Fi debugging. It actually has to be enabled, of course, but this is something that's really nice, nice to have. Furthermore, a lot of nullabilities have been added to the platform, and when developing in Kotlin, this definitely comes with a lot of benefits. Another interesting API is a crash reasons reporting. Basically, this is a system that overlaps with the crash logging systems such as Crashlytics and so on, but it allows us the power to programmatically read information about what has crashed our app and when that happened, which could be really interesting in certain scenarios. Another very interesting change is the incremental ADB, and this comes with much faster installs, and based on their tests, it actually can be up to 10 times faster than previous versions of the ADB installation. There's also a very nice feature to allow us to test all these behavior changes that happen in Android 11. It's a compatibility option change that you can change via the developer options panel. And using this, basically, you can test our the migration of your app to Android 11. Moving forward to the next section on the graphics and media side. They've added support for animated HEIF files, which are some very optimized GIF files that perform better. They've added a really nice support for refresh rates. As you know, basically devices with 90 Hertz and 120 Hertz have been showing up. And now on Surface, like if we're working on the lower level, we now have a way to set the frame rate if we don't want to go as high as the device wants to, and basically control the speed of the rendering loop. This is a really interesting thing. Also, in case we want to check when the device gets really hot, there's a new thermal API which allows us to verify how hot the device is and basically chill down the processing that we are doing. Also, moving forward on the natural, like neural networks side, basically in the NN API 1.3 that's being shipped out now, there are a lot of nice features when it comes to machine learning support on the device. This might be, yeah, these are advanced topics and not everyone uses them, but be aware that this NN API 1.3 comes with some new operations and also a lot of nice features when it comes to the how the execution control of the model happens under the hood. Furthermore, we actually get support for verifying whether the device supports 5G and how much of the network we are using. And there's also a nice support for checking or setting the biometric authentication strength that we are required. So as you know, for example, some biometric methods are more secure, such as 3D face recognition is going to be much stronger than 2D. And with this system, we have the possibility of checking whether a particular strength for the biometric system is available. And based on that, we can actually send the user to enable it, or we can handle it in our app as we require it. One of the last features I want to talk about is autofill. Basically, this is a support for, this allows support for apps such as keyboards or password managers to actually input suggestions into the Google Keyboard app. You can see it here in the image that, for example, an email is injected by the keyboard app. And for example, so like private information kind of happens the same with credit card information and all that. And yeah, when it comes to like the content, basically we get the content there. We can inject it into from keyboard apps or from password apps, and they are dealing with the security around this, which means the keyboards don't actually get the data. They actually get like they need to present a small surface where the password manager app, for example, can write. So they have a nice API based on these a couple of autofill methods. This is for the example for keyboards, and also for the password apps. They actually get this callback whenever they want to get called. They need to fill up a request. On a non-platform side, we have a lot of changes in Jetpack. As you know, like very often releases. We have Hilt. We'll actually have a presentation right after this one. This is a new Beijing 3.0 version, Camera X, and many more systems coming up. And as you know, Android Studio has been evolving quite a lot. Android 4 is out already, 4.1 is in beta, and it comes with database inspection for Lumen SQLite. And in 4.2 is where we actually get the wireless debugging and support for Jetpack Compose. All in all, there are a couple of nice videos that you can search, and basically I'll be sharing this presentation afterwards, but feel free to explore and find out what has been new in the Android world in the latest version of the app. That being said, thank you so much, and I hope you'll be as excited as I am with regards to all these new features, and that it will make our lives much easier than it has before. Thank you, Bogdan.
Nice. Those are a lot of interesting changes in Android 11. I hope all of you will check them out. I'm sure know I am. So thanks, Cosmin, for the rundown. Next up, we'll have a series of 3 presentations centered around the new libraries launched by Google to help developers with some of the pain points in Android development. If you have any questions during one of the presentations, please write them down inside the QA panel from Zoom. You can enter it from the Zoom interface, and we'll be taking all of them at the end of each talk. Right, so our first runner-up is Manuel Ernesto. He's a senior software engineer over at Disruption Lab from Angola. He's been working with Android since 2015, and he's also an organizer for GDG Lubango and GDG Luanda. He'll be talking today about the new Shiny library from Google called Hilt. This library was actually introduced during the COVID pandemic. We'll also learn why it's important to have a dependency injection library in the first place inside your project for ease of use and scalability. Manuel, take it away.
Okay, thank you, Bogdan.
Oh, Manuel, we have some connection issues. Well, that's a bummer. The demo gods are not with us today, unfortunately.
You can see my screen now?
We can hear you, and yes, now we can hear you. Yeah, now we can see your screen.
Okay. Thank you. Thank you for having me. It's a pleasure to be here today and talking about dependency injection in Android with Hilt. As Bogdan said, my name is Manuel Ernesto. I'm a software engineer at the Disruption Lab powered by Atlantic, based in Angola. And today I'm here to give a little talk about the Hilt. So let's start about the dependency injection. Basically, dependency injection is a design pattern where objects are created by an external entity or object. This means an object doesn't have to create the instance of its dependency class on its own. Depends on another object or another method. Classes often require reference to other class. For example, a car class. These required classes are called dependencies. This design pattern has many benefits like reduce the boilerplate code, make our code reusable and clean, make testing easy, and also easy to refactor our code. There are many ways to create for a class to get an object, and one way is to construct the dependency. In this example, car would create and initialize its own instance of engine car to run. So this can be problematic because car and engine are tightly coupled. That means an instance of car use one type of engine, and no subclasses or other implementation can easily be used. You would have to create an example we want to create maybe 2 instance or 3 instance of card. We need to create 2 type of card instead of just the same card for engine, maybe gas and electronic. This on engine also more difficult. Maybe car, because car are using a real instance of engines. Now let's see on this example how the code look like with dependency injection. Instead of each instance of car constructing its own engine, an engine object as a parameter in its constructor. In the main function, in this case, we can use car because car depends on engine. The app creates an instance of engine and then use it to construct an instance of car. The benefits you can see the benefits of this dependency injection approach is to reuse a car instance. You can pass in different implementation of engine to car. It's also easy to test a car. You can pass in and test the doubles to test your different scenarios. In the previously example, how to create, provide and manage the dependency of the different classes on ourselves without using an external library. This approach is called manual dependency injection. In the car example, there are one only dependency, but more dependencies in the class can make a manual injection of a dependency more tedious. Manual dependency injection also present some problems, like for big apps talking, all the dependencies and connecting them correctly can require a large amount of boilerplate code. In this case, there are some libraries that solve this problem by automatically process all creating all and providing dependency. And the first we can see there is a coding is a very simple and yet very useful dependency. Also, coin, it's a lightweight, but it's a powerful dependency injection framework for Kotlin developer. It was rightly purely in Kotlin. And there is also Dagger. Dagger is a full static dependency injection framework, which is based on annotation and helps us to manage our dependency between class. Last year, Google also announces that Dagger was officially in so this here in maybe June, Google announced a new way to use dependency injection in Android. That way is using Hilt. Basically, Hilt is a dependency injection library for Android from Google that reduces the boilerplate of doing manual dependency injection in our project. Hilt also provides a standard way to use dependency injection in our application by providing the container for every Android class in your project and managing their life cycle automatically. Hilt is also built on top of Dagger to benefit from the all good way of compile time, runtime, performance, and also scalability. We can see also that Hilt also are supporting from Android Studio. The Hilt also come with the Android X extensions. We will see in the next slide. First, how to set up Hilt on our Android project. First, we need to add the Hilt Android Gradle plugin to our project root file, and then apply the Gradle plugin and add this dependency in our app build Gradle file. We can see from this dependency, Hilt is still on alpha. Maybe something that we'll see today in the future may or may not will change. Because Hilt is built on top of Dagger, Hilt also have and they work with annotations. We can see Hilt Android annotation, inject Android entry point, and install in. We will see one by one on the next slide. So to use Hilt on our app after put our dependency, our app must contain an application class that is annotated with Hilt Android app annotation. And the Hilt Android app annotation trigger Hilt code generation. It means Hilt will include a base class for your application that serves as the application level dependency container. We can see an example of the same example we see the car using Hilt. We just need to annotate the constructor with inject annotation. That means Hilt will say that class will be used as dependency from to another class. And then to provide dependency to other classes or the Android class like activity, we just need to annotate our class or activity with Android entry point. That means this class Android entry point generated an individual Hilt component for each Android class in our project. These components can receive dependency from their respective parent class. And also to obtain dependency from component, we just need to use injection annotation to perform field injection. And on create method, we just need to call a start function from our card and just it. In Hilt, there is on the hood that we call component. For each Android class in which you can perform field injection, there are an associated Hilt component that you can refer in annotation. Each Hilt component is responsible for injecting its binding into the corresponding Android class. And for each Hilt component, there's also a annotation. You'll see in the next slide how to use one of these annotation in our project. So sometimes a type cannot be constructed or injected. This can happen for multiple inject an interface. You also cannot you don't own like a third-party library. So for solve this problem, we need to use a model in Hilt. So let's see this example. If we want on our car example use a database, in this case we can use a room database like an interface. We don't control how a room will be constructed because room do it automatically. So in this case, we need to create a Hilt module. Basically, Hilt module is a class that is annotated with a module not annotation. It's inform Hilt how to provide instance of certain type, like in this case, our database. We also need to annotate Hilt module with install in annotation to tell Hilt which Android class each module will be used or installed. In this case, in this case, for us we just need in this case to build our database and provide also in this function. Also, dependencies that you provide in Hilt module are available in all generated components that are associated with the Android class where you install the Hilt module. In this case, by default, each activity will have a different instance of database. But if you want to have on all activity the same instance of the database, we need to annotate also with the singleton annotation. That means all our activity on our project will be the same instance of our database or our database or other class that you want to inject and install. So I say that the Hilt also come with the Android X extension. In this case, we can use Hilt on view model like that. Just annotate the constructor with a view model inject annotation in on our activity of frame or fragment. We just need to do this simple line of code and just it. I think it's it. If you want to learn more about Hilt, there are two code labs from Google. The first is using Hilt in one is migrating your data to Hilt, and thank you.
Right. Thanks, Manuel. Since we don't have any further questions from the public, I'll shout my own. Are there any like performance hits from Hilt like compared to Dagger, maybe?
Yes, because Dagger there is many things to. You can say Dagger is have so many things on the background to handle with dependency injection. In that case, Hilt pretended to have more good performance comparing with Dagger. This is the promise Android team are saying. Maybe when Hilt come out on the first version, we will Dagger real comparison with Dagger because it's still in the alpha.
Yeah, gotcha.
All other thing will be at.
Yeah, that makes sense. Cool. Well, don't have any further questions, so thanks a lot for your presentation. And next up, it's one of my dearest friends from the good old days of Google+. Oh, we have one more question for Manuel. Is there an option for custom defined scopes? For instance, in Dagger, you could create your custom component and manage its lifecycle on your own, besides the Android components.
Okay, in supporting it's the custom component right now. Maybe in the future they will support this functionality.
Okay, that's good to know. Then, if there are no further questions, let's continue on. So next up is Wolfram Rittmeyer. Some of you may already remember him for some of our past events. He even came with some of our past dev fests. So that was nice. He's been in the Android fields ever since 2012, and he's been very active in the community throughout the entire years. He's a co-organizer of GDG Düsseldorf and a Google developer expert for Android and Google Assistant. Currently, he works as a freelancer, and he'll be presenting today the new way of building layouts on Android using Jetpack Compose. Wolfram?
Okay, let me share the screen. Can you see the screen?
Yeah, it's all good.
Okay, so yeah, welcome to my talk. As Bogdan already mentioned, I have been twice to your DevFest, I think, and it's a shame that this time it's not in person. Well, it's Corona time and we cannot meet in person, so we are doing this meetup. Let's make the best of the situation. So about Jetpack Compose. The background for this slide actually is the first introduction to Compose. It's made by Roman Guy. It's a photo by Roman Guy, and he's one of the developers of Jetpack Compose. And it shows a watch face, and I think an analog watch face, not a digital one. And you can see that, not here, but in the whole picture, you can see that it's made up of many small components. And that is what Compose is about. It's about us creating small UI components that we then assemble to a bigger thing, like all of the screens we're going to show the users. This is a definition from the Jetpack Compose tutorial by Google, and it says that Compose is built around composable functions. So that's the difference to before, where we had classes, and these functions let us define our API in a programmatically way by describing what we want to achieve. And that is very important. It's more or less a new trend, or we are kind of late to the trend actually, for declarative UI frameworks. This is also from the Google side, and it's the marketing blurb for Jetpack Compose. It's what they say they want to achieve with Compose, so that we all need less code to create the UI, which probably is easy given XML is very verbose and we have all to do this find view by ID and whatnot in our code. So I guess this is an easy target. Then it should be intuitive. It should accelerate development, which basically every framework says that it does. Whether it actually achieves this goal, we will talk about at the very end of the talk. And it should be powerful. Everything that you can do right now should be, you should be able to do in the future as well. And it should be more easy to achieve the same or even achieve better results than what we had before. So that's how you start. In your activity, you do not call setContentView anymore with a XML layout resource, but now you say setContent, and it's important that it's really in the activity and not in a fragment. And within this setContent, you pass in a lambda, and there you can pass in any composable UI component. In this case, the theme itself is a composable component that wraps the content and themes everything below it. And now let's go into the function content. It's pretty easy. It just displays the text, hello compose, to the screen. So the usual hello world. And it looks like that. Not very impressive, but hey, we managed to get this on the screen. Now, if you want to move it to the center of the screen, we can wrap everything in a layout. This is the stack you see here. We add some modifiers that the layout should be take up the whole space of the screen, the whole height, the whole width, and should add some padding. And then we add a modifier for the gravity, so that says basically place the text in the middle of the screen. So we achieved that. Now let's switch tack for a moment. And I was evaluating Compose for a client of mine because I have to start an app for him. And now the question is, should I use Compose? Should I use Compose partially, or should I skip Compose completely? And that's a decision many of us probably are in now or pretty soon. And it's really a bad situation to be in because, well, is Compose actually ready? If not, then we're doing XML layouts. And we know that in some point in the future, this is legacy in the near future. How near is going to be seen. So for this client, I created this small component here, which has a text field and a slider and a few buttons. Yeah, there you can slide the slider, but you can also increase the slider in discrete steps because it's of interest rates, and an interest rate of 2.79 might not make sense. So you can increase it directly to say 3 or something like that. And this is done in this way. I have this component, composable. This annotation composable actually is needed for the component to make this function actually a UI thing. Let's put it like that, the UI component. I named it pretty boringly, text field plus slider. And then again, I use a layout. Column is basically a linear layout with the orientation vertical. And I put 3 components in there, a label plus text field, that's at the bottom. Yes, a text field in material normally has a label anyway, but in this case, it should be to the left. It makes sense on the overall screen, believe me. Then we have a spacer, and below we have an adjustable slider. So 2 of those, the label plus text field and adjustable slider, you can guess from the bad names, are made by me, and the spacers made by the Google folk. And the adjustable slider, again, is made up of a layout, the row, which is a linear layout, or more comparable to linear layout with orientation horizontal, and 2 icon buttons for the minus and the plus icon, and a slider in between. So this is how you create layouts, and you can think of this more or less like a custom view, like a component view, for example. And these are really easily done with Compose. And as you can see here, there are some attributes I pass around. Just think of how you had to deal with attributes in the old way. This is an area where Compose really shines, in my opinion. So this is an excerpt of a slide from Google I/O last year. What they want to achieve is a functional UI by passing in data into the functions and then emitting the correct UI. You're not really returning the UI. It's not like Jetpack React, sorry, where you return a partial DOM, but you return a unit, but you emit the UI during this phase, let's put it like that. And another aim of the Googlers is to make really small and very specific components. You can see this here on the button. You have a normal button with text and some colored background, but you also have other buttons like an outline button, a text button where you only have the text but without the background, an icon button, and of course the floating action button. And these are all functions, so there is no inheritance hierarchy. The button actually was a sample they have given at Google I/O again last year, because the button inherits from text view, which is really kind of weird what to do with the image button. It doesn't inherit from button at all. So they have a really weird inheritance hierarchy with all kind of problems this causes. So getting rid of this inheritance hierarchy and just using functional UI should help us and should help the Googlers achieve better code more easily. Let's put it like that. As I mentioned, data goes in, so it bubbles from top. No, it goes from the top to the bottom. If you really have a large hierarchy, you can also use ambient to pass some data around, but be very careful with this. And the events bubble up again. And in between, more or less, you are not really responsible for that. The view hierarchy gets emitted. So let's see what components and what layouts we have available. So I already mentioned the stack. It's more or less like a relative layout where you, stack components on top of each other and then with some gravity place them around the screen. You have column and scrollable column, which is for vertically or placing stuff vertically. Rows is for placing stuff horizontally. You have a car for elevated elements, but you also have a constraint layout that has been ported or has been created for Compose as well. I think it's very good that it's there, and there are certainly many situations where it still makes sense, but my overall expectation is that the use of constraint layout will be reduced in the future. And since nesting of, for example, columns and rows and whatnot is not such a problem as it was with the old layouts. And then we have those two weirdly named layouts, lazy column items and lazy row items, which are basically vertical and horizontal lists. So I'm not sure about the name. I really don't like this name. I can understand putting column and row in this, but this lazy part is, in my opinion, totally superfluous, but well, it's not my decision. And we have many widgets already available. I mentioned the button and many variants of that already. We have text and images. We can create switches and stuff like that. And some more complex ones like text field or outline text field, and specific material components like a scaffold that you can use to create them, a drawer layout with a top app bar and the bottom navigation, for example. Okay. Now, any component might change over time. For example, if you slide a slider around, it has a different value depending on where on the screen the tiny bubble is. And so this is an internal state to the component, and it changes whenever the user interacts with the component or the cursor position of a text in a text field, for example. And when the state changes, we want the screen to change. And this is something that is really nicely done with Compose, because a state change automatically triggers a recomposition. So if you pass state in from outside, that's more or less obvious. Say the text of a text, the text to display of a text view changes, then it should trigger a recomposition, a redrawing of this component. But it also happens for internal state if you set it up in a certain way. And this is done by some compiler magic. So all your composables are transformed by the compiler, and there are additional parameters added to it and some statements added to it. And I don't fully understand how this works, but there's nice magic, and right now it seems to work. At least I haven't had any problem with this, though I had other problems with Compose. And what you cannot do in the future is just store a reference to say a button somewhere, and later on change the visibility of this button, or later on change the enabled state of this button by using the reference. You cannot do button set enabled equals false, for example. What you have to do is pass in some data, or so that the overall change of the state of the button changes. With the state handling itself has changed a lot. At Google I/O, they presented it as I think a data class that was annotated with @model. Whether it had to be a data class, I don't know, but the annotation was important. Then this one was deprecated and replaced by this delegate. Then this delegate was replaced by this, and with the latest version, state finally was also deprecated, and now you should use some equals remember, and then the value to remember, and that's your state. So let's see, for example, for my text field plus slider, I have a data class text field plus slider state, and whenever something in here changes, then the text field plus slider has to be redrawn. And this is done by this, together with the compiler magic, is done by this syntax. And if you compare it with React, this is from a slide that from Leland Richardson's talk he gave last year at some React conference. And on the left, you see the React component, and on the right, you see the Jetpack Compose component. And you see they are very similar. And at the bottom, at the second line, you see that they also have something like use state, where we now have remember. This is old syntax here on the slide. If you follow John O'Reilly's tweet at the bottom, you can also see this in a current version, and can see it with Swift UI compared in addition. And you see all these three frameworks, these three declarative frameworks, work very similar, which is nice, which might help some get easier to Jetpack Compose, might, on the other hand, make moving from Jetpack Compose to somewhere else easier as well. So I already mentioned the compiler magic. Now I haven't really delved into the source of the compiler code, so I cannot talk much about it. I just want to show this slide again from Google I/O last year, what the stack of a Compose app basically is off. On the left side is what we use while we develop the app. So obviously the Kotlin compiler, but we have this compiler plugin that does all this magic for us. And we have the Android Studio with the possibility to see previews of our components and to also interact with the components in the preview. And on the right, that's what we ship eventually. And we use those compose libraries. At the bottom is the compose runtime. And this library has nothing to do with UI in itself. It's just responsible for managing the tree and handling the state. On top of that, then comes a UI library that deals with measurements, layouts, canvas drawing, and stuff like that. Then we have the foundation of the UI with the most layouts, and also gesture handling, focus and click handling, which is done in modifiers. And on top of that, we have finally the material components, like, for example, the button bar or buttons or sliders, whatever. So now when we have created a component, it has to be adapted to the specific need in a certain screen. So it might have to take up a certain space on the screen. It might need a different background or something like that. And this is where modifiers come into place. Modifiers change change the component, the space they take up, maybe even the color, the style for text, for example, whether they should use rounded edges and all these things. And modifiers can be combined. And they are executed from top to bottom. Or applied from top to bottom, let's put it like that, which is really nice. So for example, you can create a padding, you can then set a background, and then, you can create a background, then set a padding, and then set a background again, so that you have an outer color and an inner color for your component. So, and this is only done by modifiers. So even if you have, so at first it might look weird with two paddings, for example, but it might make sense if you look at the execution order. And some modifiers are specific to a certain scope. For example, if you have a column, any modifier that has to deal with vertical alignment doesn't make sense and is not allowed. You can only then have a horizontal alignment within this vertical slice of UI screen. And so this is how you actually combine modifiers. You use this then keyword and you have this fill max width. So take all the space in the, from left to right, and fill max height, take all the place from top to bottom, and you combine them with then. And before we had a plus notation, so you could say modifier fill max width plus modifier fill max height, and they changed it to this then notation and made it even into a fluent API so that you can write it like this, and this looks much nicer. And if you look into the code of any of these modifier methods, you will see that they use this then internally. And if you then dig into this, then you can see on the right that it's using a combined modifier, which at the end folds all the combined modifiers together. And on the left is an interesting part. If the other element is the empty modifier, because this modifier is the empty object of all modifiers, let's put it like that, then nothing happens, and only the combined modifier is used if the other modifier actually does something. When we wanted to test the UI, which I admittedly rarely did, I mostly tested logic, but if you wanted to do that, you used to use Espresso for it. And at least Espresso, as it has been, is not suitable to Jetpack Compose. And for this, they have also created a new library. So we have a testing library nowadays. They have a testing library added to Jetpack Compose. And one important element of that is the JUnit rule, which you can use to actually put your component, the part you want to test, on the screen. And then, of course, you can do some actions on this component and finally assert that everything behaves like you want it to behave. So this is a simple test. At the top is you set up the rule. This create compose rule is in part of the testing library. And then you set the content in the middle of the screen. And at the end, I pick a certain node and check that this node actually exists. The set content method on the rule can only be run once per test. So if you put it into the setup method, you cannot change it later on in the test method. So it's probably best to put it into the test method directly and use different data sets, for example, or different stylings or some things like that in each of these tests. This is a more complex test. The setup is omitted. Just think about something at the top. And then I grab a certain node with a tag slider. I come back to it directly. And then I perform a gesture, or this code performs a gesture on it. And first, the code calculates the complete space left or taken up by this component. Then it goes to the center left, presses on the screen, taps on the screen, and then moves to the right. And at the end, it's expected when the slider slides that the text field value changes, and that is what should happen. And this is what the test here tests. And I think it's really kind of easy to use tests. So if you really create reusable components, then it makes sense to test them this way, in my opinion. One thing about this on node with tag slider, this is really something that you have to set up in your UI code. So you actually have to create something specifically for the tests in your UI code, because you have to add a modifier point test tag, I think it was the name, to make this component usable this way in a test. So I already mentioned custom views, and that this is an area where Jetpack Compose shines. And well, many views you might be created simply by actually composing other views, but not everything. And sometimes you need to draw directly on the screen, and this is possible with Jetpack Compose, of course. And you have a canvas for that, and it is very similar to what we are used to with a canvas, though we don't have a paint object. But it's close enough. You can draw circles, draw arcs, and draw images and whatnot. What you cannot do is to draw text directly on the canvas. And this is a rather stupid example that I tried out. It's named bar chart, but then draws an arc on the screen. So forget about it, but this is just showing how the canvas really works. You can use draw arc to actually draw something on a canvas, say for a bar bar chart or for pie charts or whatever. Okay. So I initially mentioned this tech stack, and tooling is a part of this tech stack. And now this is actually the weakest area of Jetpack Compose, at least in my opinion. The tooling is simply not there yet. We have a preview of our composable component. We can simply preview every component actually. The only requirement is that the function does not take any arguments. But if it needs to have an argument, then you can use this preview parameter provider. So you can pass in some data, but it's a bit different than just adding a value to the function signature. And you can also create multiple previews of one component with different data, with different themings and things like that. That is quite nice. You can even directly interact with the preview in Android Studio, for example, to set a favorite icon or something like that. But that's about it. That's all the tools that support there is. So let's first see how it's done. You have this add preview annotation, you give a name for the preview, and then you simply call the UI element you want to view. This is from the Jet News sample app by Google. And as you can see, it's using different themes here. And it looks like that. But as I mentioned, that's about everything. And it's flaky. Didn't work. For example, for my text plus slider component, probably my fault, yeah, but I don't know what's the reason for that. So if your project has some flaws in it, even the simplest components like text itself doesn't get displayed in the preview anymore. And I don't know exactly what's the cause for that. So it's not very intuitive. Let's put it like that, because intuitive is one of the marketing blurbs here. Another drawback is that it requires recompilation. So all our Compose projects right now are pretty small, but they might get bigger and bigger. So that's a problem. And you cannot use drag and drop, which is not as much a problem with Compose in my opinion, but still it would be nice if this were possible. One other thing, in the bottom corner normally of your layout screen, you have a hierarchy view of all the elements of the screen. And given that the current model or the new model is probably having much deeper hierarchies, I think it would be nice if we had this again. And other tools are missing as well. For example, the layout inspector. We have heard in the initial talk that it has improved a lot over the recent versions. And now we have this nice tool and we cannot use it with Compose. That's a bummer. So let's talk finally about interoperability. First of all, interoperability with old views. Yes, I actually haven't used it yet. But from all what I've seen, it is possible, but I'm not sure if it's a good fit because the programming models of both worlds are very different. I'm not sure how good they really will interoperate with each other. That's something I have to dig into a bit more, and that has to be made more explicit. I think some custom views, for example, would be nice to be usable within your composable trees. And on the other hand, custom views are really easy to create in Jetpack Compose. So that would be nice if you could use them even in your old layouts, because old projects, you are not migrating them in one big bang. The other thing is Jetpack Compose is part of Jetpack. Well, Is it? I'm not sure. Really, we will hear about navigation in the next talk by Carlo, and I'm not sure how it's going to work with Jetpack Compose. Maybe we could talk after the talk about this specific thing. I'm not sure right now how view model and Jetpack Compose will work together. And since I expect Jetpack Compose to be in alpha, to be released as alpha this week, I kind of wonder why these things haven't been touched on right now. There is some support for live data, but overall, the interoperability is not there yet. And at Google I/O last year, they already had this slide. And in my opinion, the situation hasn't much changed. So back to this slide, that's my final slide. Do we have less code? I think there's a check mark for that. Yes, they achieved this. Is it intuitive? I'm so used to the old model that it's probably unfair to ask me. So if any React developer would say, yes, it's very intuitive. For me, the old model is still more intuitive just because I'm used to it. But overall, I liked playing around with Compose. So I think I will switch as soon as it's viable. Will it accelerate development? I think that's the area where they actually have the most work left for them to do. The tooling really needs to improve, and the integration with these other Jetpack libraries has to be there to really accelerate our development. And is it powerful? I think it already is powerful. For example, the theming support is really good. Other things, obviously, it's pre-alpha, are not there yet, but I guess that in the end, when it's released, powerful will also get a check mark. So accelerate development, that's really the thing they need to improve on. And with that, I'm done. I'm a bit over the time, I guess. So Bogdan, are there any questions? Sorry,
I was muted. Yeah, there are quite a few questions, but I'll go first. How many years do you reckon it will take until it's like properly usable in production?
how long until this is usable in production? Yes,
Like
I think
properly.
1 year from now. I'm not sure, but I guess, yes, I'm optimistic. I guess somewhere, let's hope, early summer, late spring, it might be better. And then I hope at the end of summer, at the beginning of autumn, it could be production ready. I hope so. Yeah. Well, I'm not sure if it's optimistic. It's still a year, and a year we all are in a kind of limbo. Should we use it or should we not use it? So yes, so it's a hard year for us.
Yeah, it sure will be. Moving on with the questions, we have a question from Robert. Do you think this is the direction that Google is headed towards when it comes to the UI for Android?
Yeah, definitely. I think all the people of the UI team are not working exclusively on that. We have seen, for example, Constraint Layout 2.0 was released this week. But yes, I think they are working very hard on it. And this is definitely the direction. I already mentioned that it's comparable, for example, to Swift UI or to React or to other web frameworks. And I think overall, the direction of UI toolkits is going to this declarative approach. So yes, that's the way to go. And you should start playing around with it.
Yeah, sounds good. We have another question from a video. Is Compose using native widgets behind the scenes, or is it more like Flutter, which draws them from scratch?
I'm not entirely sure when it comes to text, for example, but in general, it's drawing things directly on the screen. It's not using the view base class, for example.
All right. A follow-up, kind of on the same note from Saba. How much does Jetpack Compose is in relation with Flutter's native Compose-like framework? Could there be any sublinear algorithms or constant factor optimizations brought over, or that's out of the question because the native UI is still the underlying presentation layer versus Skia in Flutter?
I'm sorry, I have no idea. I guess that these are still different layers, but I don't know. Sorry.
All right, no worries. And one more from Arthur. Do you have some tips to make transitioning from the old UI toolkit model to the new Compose model easy?
To make it easy. No, I think it's more or less like when we migrated to Kotlin, assuming we all did. You didn't do this in a big bang. So all the screens you already have probably will stay with XML if you have a large app, but you're adding new screens and then you start with that. And if you have to redesign a screen, for example, entirely, you should or might move then to Jetpack Compose. And maybe I already mentioned that maybe it's possible to partially use Compose, for example, for custom components. I'm not sure about that either, but that's my expectation that you can do that. And apart from that, I would really move screen by screen. Having said that, screen by screen, I'm not entirely sure what the screen will be in future. Will we still use fragments? I personally think not, but I'm not sure about that. I expect only composables to swap one composable for the other. But this is another thing that Google has, well, doesn't have to tell us, but it would be good to get some guideline by Google for that.
Yeah, the whole transition away from fragments will be a major pain, yes, considering like everything we've built in the past few years is based on that, right? So
yeah,
I don't even want to imagine what's going to be up with that. Yeah. One last question from Alexandro. Is there a plan for handling complex states similar with Redux or reducers on React?
I'm not aware of anything, but I expect Google to offer something of it, if it's similar to Redux or stuff like that, or if it's anything different, or if it's just stays view models with specific state just for certain parts. I do not know, but I guess that we will get something, which I do not know.
We shall see. Well, if there are no further questions, thanks a lot, Wolfram.
Okay, thank you.
And last but not least, we have Carlo Lucera, also known as Hadroid. He's a tech enthusiast and an Android developer, always in search of new technologies and strategies to improve. We'll learn today about how to properly perform navigation inside our apps using the navigation library from Google. Carlo, heads down.
Thank you. Let me show my screen. Okay. Okay. Thank you everyone for joining. I'm Carlo. You can find me around the web as Hadroid. And we now will discover an easy way to handle our navigation. I have here someone concerned about the fragments. But if you use the navigation, this can be addressed in an easy way. Let's see. Just a moment. Okay. Basically, what is the navigation library? Navigation library is a way to simplify all the navigation inside our application. Usually, we have some kind of trouble to handle out the navigation because in Android, you should remind which fragment where is placed ideally in your application. You don't have anything pointing out how they are connected or which activity where it goes. But with navigation, you can have a simple graph that show you how all the fragments in your application are connected. And this is really a good approach, because in an instant you can see that from the fragment main, you can go to the transaction, you can go to choose a recipe, you can specify the amount from then, and so on. Navigation can be used with several type of objects. For example, you can use to navigate from fragments, and this is the most used approach. You can use it to navigate between activities, and also you can have custom destinations like custom view. We will see what a destination is later during this talk. And also, I not specified it here, you can even have more than one navigation graph. My most useful advice is to use the one activity method. So you have one activity with one navigation graph, and then all the destination inside it will be fragments. But if you need, you can have even more activity, each with his own navigation graph, and then you can have a more complex navigation. But basically, why we should use the navigation? We should use the navigation because it simplifies the way we approach our pattern. Because let's see what we should do to navigate in classical navigation to go from a fragment to another. First of all, we must check if our fragment container exists, because we can't put a fragment inside a view in a view that doesn't exist. Then we should check if it's the first time we are in this activity or in this fragment, because we might reload the same fragment for accident in the same container, and this is not good. Then we have to do the actual transaction. So we have to get the support fragment manager, we have to begin the transaction, we have to replace or add the fragment that we want to show in the current container. Then if we want to add it to the backstack, we must explicitly declare it. And so we basically must manage all the navigation by code. And this navigation, we don't have any idea how it's connected. We must know how each fragment is connected, but the ID don't tell us anything. If we have already something in the backstack, we have to check, we have to do a lot of code just to understand where we are in our navigation. With the navigation library, we have the directions and the destinations. The directions is a special class generated by the safe arguments plugin. We will see that later. And basically, when we have a navigation library, we are using the navigation library, we just have to create our direction, and then find our navigation controller and navigate to that action. To find the navigation controller, we have several ways. Even if you're using Kotlin or Java, is almost similar, but with some difference. But basically, if you have any activity or view or fragment instance available, you can find your navigation controller. And then, as I said before, you should handle the backstack navigation. What does it mean? In classical navigation, you have to add to the backstack each fragment. And you have to skip to add the fragment that you don't want to have in the backstack. Many times this can be confusing when you start coding, because you tend to add all the fragment to the backstack, but for example, the first fragment of an activity should not be added, because then when you go back, you will end up with empty activity. In the navigation, everything is already, the information of the backstack is already in the graph. The arrow you see are the direction, so you already know that your fragment main is the first one, and as you can see from the home icon, is the landing point of your graph. Then from this fragment, you can navigate to other fragments, and only those are added to the backstack. And when you go ahead, you go back following the arrows. And also, what's helping in the navigation library is the automation of the transaction. Because as I said, you don't have to replace or add or choose what you have to do with your fragment, because everything is already included in your navigation graph. When you specify your action, you can also add your arguments. In the navigation graph, you have once you select a direction, you can easily specify which kind of arguments you want to put. You can use integer, float, string, or even your custom class. It should be implement parser label, but it can be passed as an argument. Then the Safe Arguments plugin will create a special class for you, will generate it. Basically, it's the name of the fragment followed by direction. In this class, you will find for each direction, for each destination you have created in the graph, you can find the relative action, and you will find the parameters that you can use. One of the most important things when you use the navigation, or you use fragment navigation in general, is how can I animate the fragment transaction? Because if you know the traditional way to animate, it's really complex. Because you, during the transaction, have to add the in animation, the out animation, the pop animation, and everything has to be done by code. If you check on Android developers website how to animate the fragment transaction, you will find a really, really long guide on how to implement these animations. But how can you implement the navigation animation with the navigation graph? As you see, this is your navigation graph. This is a really simplified one. The home fragment is our first destination and our home destination, and the fragment 1 is our second destination. I created an action. Basically, you just drag the arrow from home fragment to fragment 1, and you create a destination. It means that the SafeArgs argument will generate the current action, and I just have to call it to move from fragment 1 from home fragment to fragment 1. But if I want to add an animation, how I can do it? Simply click on the arrow, then click on the enter animation. You will see on the right we have the animation panel. In the animation panel, we have the enter animation, the exit animation, the pop enter and pop exit. Simply you click on this button, and then you can select the animation. You can select one of the current existing animation, or you can simply create with clicking on the plus button. You can even create it by code and reference it by this window or just in the animation panel. Then you are done. Your animation is already set, and every time you animate with this action, you can see the name of the action on the panel. You will have this kind of animation. So it's really easy. You need to pop in a different way, just implement the animation in this way. Then let's see what the navigation graph really is. Basically is what we can use to visualize all the navigation inside our application. To check the navigation graph, we have to use the navigation editor. The navigation editor is from Android Studio version 3.3. It should be not a problem because now we have 4 and more. But when I started, is basically only on Canary version, and it was really bugged, but now it works just fine. It's fantastic. So this is a classic navigation graph. You can see we have all the possible destination. Each destination is connected with an action. In the action, we can also specify how much we have to pop, because, for example, if we want from trivia, from the end of the game, go back to the first screen, we can just specify in the two actions that go from the in-game to the game win, game loss screen. We can just refer the title screen to go back when we pop. Or you can have a completely different path, like the one on the leaderboard, from the leaderboard on the user profile. This kind of graph can become complex as you need to be. Just to create the navigation graph is as easy as creating a new resource. Right-clicking on the resource folder, you can choose Android resource file, and then you, if you have installed the navigation library in your build Gradle file, we will see that later, you will find the navigation as a resource type in the next window. Then, what we have in the navigation graph? Each screen is a destination. As I said before, it can be a fragment, it can be an activity, it can be any other custom view. When you use the navigation graph, let's go back a little, you will see that in the top of the navigation editor, you have the plus button, and you can add a destination. From there, you can just create a new fragment, or you can attach a fragment already created in your code. And then we have the action. The action is what defines how the transition should be. In the action, you can specify any argument you may need. You can specify the animation and so on. So let's see how you can import the navigation library. The navigation library is a simple 2-line of code in the build.gradle. The current version is 2.3.0, and you can have the import for Java or for Kotlin. Then you need to implement the feature module support to have the navigation editor and all the resources you need to handle the navigation graph. This is the import for the Java version, the Kotlin version, and the feature module support. Let's see how to implement the SafeArg plugin. basically what I said before, if you have the SafeArg plugin, you don't have to specify by code your actions, because all the action will be generated automatically. In your app Gradle file, you should add this plugin at the end of the build Gradle, like you do with the Google Services plugin. And then in your dependency, you have to add the class path to the navigation safe arcs. This can be, this should be done in the top level Gradle file, and the version should be the same of your navigation dependency. Thank you. You can find me on Twitter. If you have any question, I'm here to answer that.
Right. Thanks, Carlo. If you guys have any questions for Carlo. Robert is asking, do you still need your objects to be parcelable to pass them between fragments or activities in this paradigm?
Yes, it's need to be parcelable if it's a custom object. Of course, you can use any basic class like string, integer, but if you need something more complex, you should use parcelable. But if you have some really complex object, the best approach is to use a view model to handle the data.
Cool. Any other questions?
Hi, I also have a question. Unfortunately, I cannot write in the Q&A, but I can ask directly, I guess. So, Carlo, I was wondering if you have any experience with how you use the, or how to handle this navigation when it comes to multi-module applications. So, like Google has been encouraging app developers to kind of split their apps in multiple modules, but the problem is that from one particular feature module, I cannot see the directions and safe args in the other feature module. So I was wondering if you have any thoughts or input or like help on that.
No, I never used it in multiple module projects.
All right, yeah, but apparently like, we are working on some projects which have that, and unfortunately not a lot of people have been doing that. So that's why I was hoping for a bit more thoughts on that. All right, thank you so much.
No, the most I have done is to do the multiple activity, each one with its own navigation graph, but this can be handled with the same module, so it's not the same issue. I'm sorry.
Yep, no worries. Robert has another question. How would you do that with a custom view, considering its lack of life cycle?
I didn't use it with the custom view, so I can't answer. But it's easier to have a recycler view inside the fragment and then handle from that. It's not used for the recycler view. It's more if you have a completely custom view.
Yeah, that makes sense. All right. Then if there are no further questions, I guess that's a wrap. Thanks, Carlo.
Thank you.
So thank you all for joining us today in first learning a bit about the new stuff in Android 11 and also the recently launched libraries from Google. We hope you had a great time and learned something today. The entire GDG team would also like to thank our lovely speakers for joining us today and taking the time and effort for our presentations. We would more than love to have you over after the whole COVID period is done over here in Bucharest in person. So thank you all and have a wonderful day. Bye.